In this video, we're going to discuss the case study questions on polynomials. Before getting into the questions, let us see what is the meaning of zeros of polynomials and let us deal with some graphs. Zero of a polynomial means it is an input value for which the polynomial is completely becoming zero. If you see with respect to graphs, let us see a linear polynomial. It gives you a straight line on the graph. If you see this particular straight line, which is meeting x-axis at x comma 0, so x is the 0 of this polynomial, which is a linear polynomial. But if you see the second line graph, which is parallel to the x-axis, it is not cutting x-axis anywhere. So that is why it doesn't have any 0. Now let us take a quadratic polynomial, which is cutting the x-axis at two locations. For every quadratic polynomial, there will be two factors which will give you two roots at maximum. Why am I saying maximum? Because if you draw the graph of it, it will cut x-axis at two locations at alpha and beta. This is when the roots are unique, which means the discriminant value is greater than 0. But when the discriminant value is equal to 0, the alpha value and beta value will be equal. You can see this situation explained in the green color graph, touching x-axis at only one location. So which means it has only one unique 0. When the discriminant value is less than 0, the graph of the quadratic polynomial will not touch x-axis at all. So you are seeing a purple color graph which is having no 0, which means it is not cutting x-axis at anywhere. So that is why the number of 0 for this polynomial is 0. In the same way, if you take a cubic polynomial, it will have at maximum 3 roots, which means 3 zeros. Here I have given alpha, beta, gamma as the 3 zeros of this polynomial. But in case if you draw the graph of a cubic polynomial in the other way, here alpha and beta are equal. That means here those two roots are becoming equal and making one single unique root, and there is also a gamma root. So totally there are 2 unique roots, even though there should be 3 roots for a cubic polynomial. Hence, for this particular graph, we can say there are 2 unique zeros for this polynomial. Now let us move on to the question. In this question, the information about the definition of 0 of a polynomial is already given. And let us see the question here. First question, the graph of linear polynomial is a straight line and it cuts the x-axis at exactly how many points? Answer is 1 point. We have just now discussed it. And second question, the graph of a quadratic polynomial is a parabola and it cuts the x-axis at most how many locations? So definitely 2 points. At most 2 points. It cuts even at a single point also. Third question, the graph of a cubic polynomial cuts the x-axis at most how many points? 3 points. In the same way, fourth question, the graph of an n degree polynomial, which means nth degree polynomial, cuts the x-axis at most how many locations? Maximum, it can cut n number of locations, which means n points. In the last question, p of x is given as 2x squared plus 5x plus 3. He is asking, out of all these options, which one is carrying the 0 of this polynomial? Just check all these options by substituting in the given polynomial. Whichever option is giving you the answer 0 upon substitution, then that answer is correct. So here by substituting minus 1 in place of x in the polynomial, I am getting 0. So that is why minus 1 is one of the zeros of the polynomial given. Now let us move on to the second problem. Here there is a graph given and this graph is cutting x-axis at 3 locations and y-axis at 1 location, as you can see. On that different questions are given, so let us explore those questions. First one, number of zeros of this polynomial is equal to the number of points where the graph of the polynomial intersecting origin, intersecting x-axis, intersect y-axis and cuts y-axis. Intersect x-axis is the correct option. And second question is asking about zeros of the given polynomial function. So as you can see, where the graph is intersecting x-axis, those locations are nothing but the zeros. So minus 4 comma 0, minus 1 comma 0 and 3 comma 0 are the locations at which the graph is intersecting x-axis. So that is why fourth one is the correct option. Next question, the maximum number of zeros of this given polynomial are definitely 3 because it is cutting x-axis at 3 different locations. So that is why it is equal to 3. Now go for the fourth question. Which of the following graphs does not have any 0? So the graph which is not cutting or intersecting x-axis at anywhere does not have any root, any 0. So that is why here only the graph given in the second option is seeming like that. So that is why second option is correct one. And let us see the final question. The graph of y equals to f of x is given. How many zeros are there for this f of x? This graph is not even touching x-axis at all. So that is why the number of zeros of this polynomial is 0. Now let us see the final problem for today. In this problem, a formula is given to calculate the concentration of a drug in bloodstream after T hours. So C represents the concentration of the drug in parts per million and T represents the time. Let us explore the first question. The given equation represents, here the maximum power is seeming 2, so that is why the degree is 2, which means it is a quadratic polynomial. Let us see the second question. After how many hours the concentration of drug in the bloodstream becomes 0? So the concentration C should be equal to 0. So let us make C equals to 0. Then we will get T square by 2 minus 2T plus 2 is also equal to 0. Then this is simply a quadratic equation. Factorize it and find the roots of it, which are equal to 2 or 2. So both the roots are same. That is why we can take T equals to 2. So after 2 hours, the concentration of the drug in the bloodstream will become 0. Question number 3. A polynomial that consists of a non-zero constant is called. Yes, constant polynomial. Option 1 is correct. Let us go for question number 4. The C of 0 equals to 2 represents, it is a constant polynomial, because whenever you see a constant, that you call a constant polynomial. And in the final question, the C of 0 equals to 0 represents a zero polynomial. Here we have to observe one thing. I can take the constant polynomial 2 as 2 into x power 0. 0 power means it is a non-negative power which satisfies the condition for polynomial. So for a constant polynomial the degree is 0. But if you take a zero polynomial, I can take it as f of x equals to 0 into x power 0. I can also take it as 0 into x squared, 0 into x power 10, 0 into x power 12. So all these are zero polynomials only, but with different degrees, different powers. So there is no fixed power for a zero polynomial. That is why the degree of a zero polynomial cannot be defined. If you find this video helpful, please share with your friends. And with another topic for case study questions, let us meet in the next video.